Patterning control. Now we will discuss about the contact time and its effect on the patterning, how we can play around with it to optimize our patterns. First of all, what is the contact time? The contact time is the time that we spend in contact with our surface when we pattern every pixel. So in the software we have what we call a pixel time, which is the total amount of time that we spend for each pixel, which you can use to calculate the linear speed of patterning. But this value is not the contact time. So the time that we spend in contact with the surface is less than the pixel time, and it's can be approximated to what we call force pulse time in the software. So what is the force pulse time? The force pulse time is how long does the force pulse last whenever we bend our cantilever. So you can imagine that after we apply this force, there will be a slight delay in the actual bending of the cantilever. So the force pulse time is not exactly equal to the contact time, but can be approximated to the contact time. So let's go to the NanoFraser software to have a better idea of what we're talking about and to see better the parameters we're working with. So the force pulse time can be found in the timing parameters. The default value of the force pulse time is 5 microseconds. You see that the pixel time is 5 times larger. So every pixel takes 25 microseconds, but of these 25 microseconds, around 5 microseconds are in contact with the surface. So now I just did a pattern of a sine wave with a Kalman feedback. Can use the last converted state using 250 nanometers forward height and 950 Celsius. So we can see in the analysis panel that we were using a force that was ranging between 2.4 and 3.4 volt to pattern. So we can also put here, let's use an initial force between 2.4 and 3.4 volt. This was the force that we used for the last lines here. And what we want to see is the effect of the force pulse time or the contact time. So what happens if we increase it to 10, for example? So we may expect that if we increase the contact time, we are increasing the energy that our surface, our substrate, which is coated by PPA, but in general, of course, the PPA receives. So more energy, thermal energy received means more material being sublimated, so larger depth of patterning. While in contrast, if we decrease time in contact with the surface, we're decreasing the amount of energy that is being given, so we are patterning, we're removing less material. And in this sense, this is a quite intuitive way to understand this parameter, and it can be almost compared to sort of a dose parameter that we can regulate with the NanoFraser. So let's try to pattern now. So we change the contact time to 10, so we doubled it, and we expect that we will use we will start patterning deeper, and we will use a smaller force than this 2.4 and 3.4 volt to pattern with the same with the previous timing parameters, so force pulse. So let's see now. Yeah, we see already that the first initial lines are quite deeper than the previous one, but now then we're patterning with a feedback, so we are adjusting we are adjusting to this new timing parameter, and we can also check the analysis. We reduced our force from 2.4 to 2.1, and the maximum force that we apply is around 2.9. And yeah, these timing parameters cannot be changed while patterning, so we may stop here. To move down. Move down, and we can pattern again, but maybe using a different timing parameter. So instead of 5, which is a standard value, we can put 1. So 150. It's quite a large change. And let's start the patterning. So we use again this 2.4 to 3.4, which was good for the first field. Now we will see that instead of patterning at a good depth, we will pattern too shallow, because the force pulse time is much decreased. So we see that we're not even able to pattern, and we're also raising the forces quite a lot. So we're almost pattern, we see here, at 7 volt maximum force, and minimum force is around 4.8. But you can see that it seems like we're patterning quite well, completely different force parameters, but it's very clear the effect with the response of the feedback, because we are using a force that's much higher now. So the force pulse time and the contact time is usually a parameter that is not very often changed, but it can be helpful if you think that you may need a larger dose for a more efficient patterning, or it can also be reduced in some cases to pattern in high resolution. So some of our internal users at Heidelberg Instruments of the Nano Fraser like to pattern, for example, in high resolution with a low force pulse time, keeping a temperature of 950, because usually it's harder to pattern at high resolution keeping this temperature with this the standard force pulse time. So that can be another option. And another thing that I would like to mention, since we are in the area of timing parameters, is just a few details regarding the pixel time. So the pixel time is the total time that we spend for each pixel. So you can imagine that if we increase this time, so let's say instead of 50 we put 100, we will spend 4 times more for each pixel. So we will increase the total patterning time because the patterning speed is reduced. Well, if we decrease it, let's say we put 15, we will also reduce the patterning time because the linear speed will be much higher. So this is something to also keep in mind, because when we increase or decrease the patterning speed, we also change the dimension of the scan speed. It can be sometimes too large to fit in the piezo range. So we see now if we have an extension of around 10 microns, if we put this back to 150, for example, we'll see that we have an extension of less than 2 microns. So it's a parameter that it's nice to know and nice to know to play around with.